Yeah, if you could keep the blue sheets circulating around the room, your job is to pass them on to the next row behind you. Behind you. So keep the slide. Blue. Hi, Kanchana. Dr. Kanchana, are you ready to go first? You are the first one. So we're going to get started in 1 minute. And Dr. Kanchana, welcome. And many here. I'm Jane. I'm co-chair of Gaia. And I believe we have Leandro Navarro, who's the other co-chair online here. I can see him. Welcome. Give me 1 more second. So if you're sitting in this room, welcome to Global Access to the Internet for All, a group that was started by some colleagues of ours from Oxford University and beyond and Cambridge University. I am Jane. I am the co-chair of Gaia with my colleague Leandro, who's with the University in Barcelona, UPC. We often bring experts from regions, wherever we are, to speak about some of the connectivity projects they're working on. Our objective is to bring in real-life examples of the way you create networks in rural, remote, and urban underserved communities and in very difficult places to connect. Last week, I was in Tbilisi, Georgia, where we have a community network project with many people in high mountain villages of about 4,000 meters and up. They're actually using LoRaWAN. So when Jonathan Brewer speaks about LoRa, this is very much something that people are implementing in real life in places that are so remote that you have about 600 people in a very, 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 very complicated and remote area. So it's doable. Some of our teams have taken helicopters, some have taken horses to bring equipment. I know Dr. Kanchana sometimes is working with elephants. These are real life solutions for people who are not connected. So we are dedicated to connecting people. Obviously, the whole IETF's focus is connectivity, but many of you know what it's like to do the real life complicated things where something may not work. Last week, a friend of mine had to hack a solar panel because the solar panel wasn't working through the throughput from the batteries was just not working. They pretty much cut all the cables to all the batteries and rewired the whole thing on the side of the mountain, not even close to spec that had been submitted. So as many of you know, you'll often get some equipment that's a little wonky, maybe not working, and you just hack it on the ground. So this is part of what we do, all of you do, and we try and support that with the different projects that I know Leandro and others work with. Leandro is part of something called GUIFI, which is one of the largest community networks in the world. It's out of Spain. They have many, many different users, but they also have fiber, wireless, and Wi-Fi. So they're using different technologies. They've actually trenched their own fiber. So these are very interesting communities that are being worked with in Spain as well. So on the agenda, if you check online, the first person up is Dr. Kanchana, who's a good friend, and she's also an Internet Hall of Famer and a Postel Award winner. So I will also just ask you, it's protocol for me to tell you to take advantage of the Note Well, which is online. I'm not going to show it here. People make fun of me for showing it. So for those of you that don't know what it is, take a look online. It's the Note Well for the organization, for IETF. So Dr. Kanchana, each person will have 10 minutes. So Kanchana, I'll give you a warning 8 minutes in. We have note takers. Can someone raise their hands just to make sure we got, oh, awesome. Thank you. So let me cue up your slides, Dr. Kanchana, and please, you come up here. There's an X on the floor, and you speak into the microphone. So I'm going to stop talking, and I'm not monitoring Jabber, Leandro, so if you're trying to reach me, I'm on WhatsApp.
What happened to Arjuna?
I'm sorry? Who? Arjuna's not speaking, so if you look at the new agenda, Arjuna's not on it. You're first.
I was supposed to be the last. Is it on? Okay. Thank you.
It is on.
Right.
Hang on. Downloads. So can you introduce yourself?
Yeah. Okay. My name is Kanchana from Technology Thailand, and I've been involved with building the network for quite a long time, knowing many people in this room. So I'm very happy with this agenda that we have many more presentation from the region like Indonesia, Philippines, and so on. So it's a place where we can learn from one another. For the Thai case, I myself work for the Asian Institute of Technology, and my team work with Net to Home company and also Beaconix company, which is running the community IXP. So my job is to try to see how these two community can eventually work with together. So this is the starting point of their collaboration. So I like to talk about that to the next, please. I'm not familiar with next, please.
Sorry, there's always a little fun with these slides. There we go. Okay,
Okay.
You're up now. There you go.
Okay, the network that we set up is in Tak province, TAK province, which is on the Burmese border. We have, our northernmost network is kind of 60 kilometers from the rest, and the rest of them are in a small cluster in an area north of Masot. So we have at the moment about almost 20 community that become our member. So we call the whole group as TACnet. Okay. Next, please. We started to work on this since 2013. We went into a village next to Myanmar, and we found that within that village they had only 2 ADSL lines, and they had to pay $33 per month for subscription, and only less than 10 people benefit from that. So we went in and built our mesh network in the village and try to use existing ADSL line to the internet as the line to the internet. And by today, we have about 21 sites. The internet cost is shared by the villagers, and it costs them $8 per month for subscription. And we now have over 1,000 users. Next, please. So this is a picture of our network. You have a wireless mesh network inside the village, and we have a gateway to the internet. And by today, the gateway to the internet is using the commercial ISP, and they provide a fiber connection. And we have a small Raspberry as a server to perform gateway management. Next, please. Now, in order to use the internet connection and shared among among many people with the subscription that we did, we risk the problem because we risk the chance of being arrested because we were selling the internet services. So we had to register a company called Net to Home and become legal internet service provider and take charge of administration of the network. Okay, so the net to home is an ISP legally, and it's a type 1 ISP in Thailand. It means that you cannot own any infrastructure. You can sell the internet without owning your own infrastructure. You can sell internet access. You can operate anywhere in the country, and the type of users is general. So net to home company is taking care of the financial collection of the subscription and pay to the ISP, and it is open to the community to share, to buy, to become a shareholder of the company. Next, please. So this is our net to home company. At the moment, we concentrate on the western border of TACnet only, but we plan to deploy the same model in many different provinces in the near future. So the idea is that we have internet community network connects to the commercial ISP who owns the network, who own the infrastructure. So we don't need to invest on the infrastructure, long haul infrastructure. And we want to have community networks that our member to talk to one another and exchange information. And we want our community network to be able to share common resources. And besides, the network that we have at the moment depends on who are the internet service provider. So some community network join one provider, another one join another provider, and sometimes the provider, these two providers, do not talk to one another. So it's hard for us to manage the community. So we want to have more homogeneous environment. So we want, in this way, we try to connect. This is the reason why we want to connect everyone to one IXP. Next, please. So we want to have, because of the problem of the different heterogeneous ISP, we want to have a more common ecosystem for all in the our members. So we want to connect everybody to a common IXP. Apart from having them talking to one another, with a common IXP, we can kind of take care of the control. We can control the routing, so that if any problem arises, we can easily understand what happened. If we let them use the different ISP, and if something happened, they'll come and ask us, and we have to figure out what's wrong with this ISP, with this ISP. Okay, so we need to have common picture for all. So besides, people are starting to communicate domestically. They don't use the internet to go out of the country. So our we tested our design and it works. So next thing that we want to do is to use this kind of connection to the IXP to provide more interesting services to the community. Because right now, when we ask our user what kind of application you want to have on the internet, they all want streaming. They want to watch television. They want to do always video. So of course we can tell them this is not for it. You can't afford that. But this is not a long-term answer to them. So we have to work out how to handle streaming application. We have to do video. So we are working on that, and we try to work on using proxy and cache servers, which is like what we used to do in the old days. For Thailand to connect to the internet, we had very limited bandwidth, so we had to use proxies in the old days. So, and we want a common service. We want to provide cloud in the future, and we want our members to peer with other IXP members. Next, please. So we don't own any fiber link. We don't own any infrastructure. So how can we connect to IXP, which is in Bangkok, about 600 kilometers away? So we decided to use tunneling. We just tunnel through ISP that the CN connected to, and that tunnel ends at our IXP. Okay, so next please. So this is what happened. You have our community. I would call our the IXP we are working with, BKNX, is also community IXP. And with the community IXP in the top part of the diagram, you have CDN, international CDN that are members, and we have also local content providers. So you can have TV channels that share contents to the IXP. And we also have different ISP. Okay, ISP on the left are ISP that our members and the villagers connected to them. IXP on the right-hand side are those who are not members of BKNX, but our villagers had to connect to them because no other choice. So with this design, we have IP tunnel, the blue line, to connect each community with community network to our net-to-home border router, and that border router talk to IXP. So this is how it works at the moment. Next, please.
2 minutes.
2 minutes. Okay, let me mention our partner, BKNX, a little bit. BKNX is our community IXP. Jane helped us set up this BKNX 2013, since 2013. Yeah. So, but it was established in 2015, and now we have 29 AS members, and peak traffic is 36 gig, and average traffic is 12.27 gig. And you can find more information on this website. Okay, so with that connectivity that we have succeeded, we are now working on content delivery in net-to-home. Net-to-home is a company that represents all the community networks on the previous diagram. So we are working on how to cache popular content that people are using, and we also working on reverse proxy, how to gather content from the villagers and upload to the internet. And we have our working on our local service, which is a platform for resource sharing. So it's like Uber. Okay. Next, please. So I'm done. Thank you. I'd like to thank TSNIC Foundation for all the support that they have given, and all the team members from these three, from my lab and from Net to Home and Bikini Company, and also the community members themselves. They take part in our activities. Thank you. And of course, thank ISOC
Our pleasure.
to get us started.
We have a minute. Does anyone have any questions for Dr. Kanchana? She'll also be here this afternoon. She's a person who brought the internet to Thailand, so all respect. So
No, I think
one of
what
the
I'm
people.
doing now is like repeating my experience again. After 30 years, I go through the same cycle.
Curtis, you have a question. Can you announce who you are when you step up to the microphone? You don't
Announce
have
who I am. Yes.
Yeah.
Okay. Hi, I'm Curtis Heimer at the University of Washington. Hi, Kanchana. I'm curious about, you said that you're doing some caching at your community network level. Like, what are you using for that?
Because you have limited bandwidth.
Sure.
So-
this is a more technical question. That, like, what are you using? Like, what software stack? What sort of?
At the moment, we are evaluating many different. We have not decided at the moment. If you have any suggestion, we'll be very happy.
I was hoping to get the suggestion. Yeah. So, okay, we'll talk about it later.
Okay, we'll have a caching conversation later. Thank you very much, Kanchana. Okay, on the agenda, we have, next is Jonathan Brewer, and Jonathan's going to give us a bit more data on LoRaWAN, which some of you know something about. Give it that clicker a try. Working or no? I'll forward it for you.
Oh, that's the laser pointer.
Yeah.
No,
Whoa, this laptop. Oh, yeah. Okay.
yeah, sorry.
It's okay.
All right.
Okay, Jonathan's up. And this
Hello.
is a real thing. This is being deployed in community networks in a lot of parts of the world.
Yes, indeed. So I'm John, and I'm going to talk about LoRaWAN, which is a network, and the Things Network, which is an organization that offers the equivalent of a mobile network controller for LoRaWAN IoT networks. Slide, please. So what is LoRa? LoRa is a physical radio protocol designed for the Internet of Things. It operates in lower than 1 gigahertz ISM bands. So whatever happens to be free in your country, in this part of the world, it tends to be around 923 megahertz. In New Zealand, we have a band from 864 to 868. We also have a band from 915 to 930. I should say that I am staying in Singapore temporarily right now, but I live in New Zealand, and you can tell I'm from New Zealand because of my accent. No, sorry, I'm actually from the States, but New Zealand's been home for a long time. So LoRa is a radio technology that's proprietary to a company called Semtech. And I know that kind of sucks that it's proprietary, but when you look at things like Wi-Fi, which is the foundation of community networks all over the place, there is proprietary intellectual property in Wi-Fi, and license fees gets paid through and so on. So it's not all that different. So anyway, Kanchana's network, the TalkNet mesh, that's tens of megabits per second, and their backhaul is 200, 200. So you're talking broadband. And this LoRaWAN stuff is like 250 bits per second to maybe 22 kilobits per second. But really the topologies and the applications that I've been working with over the past 4 years have been in the range of a kilobit per second or less. Next, please. So what is LoRaWAN? So LoRa is the radio protocol, and you don't need to use LoRaWAN to use LoRa. You can actually make a point-to-point connection with LoRa modems. Some people use them for controlling drones. Some people have used the LoRa protocol for other network types, but LoRaWAN is an open, non-proprietary standard for a wireless network. And it, as I said before, the whole thing with the mobile network controller, well, LoRaWAN adds addressing, mobility, and localization to LoRa. It adds this whole idea of you can have a network with lots of base stations, devices that move from one base station to the other, and everything just kind of holds together. So with LoRaWAN, it's pretty cool. Multiple base stations can receive and process packets. So like if this clicker were a LoRaWAN node, like out there in the network, he sent out a message. That message would be picked up by any base station that's in this room, and all of those base stations would relay the data to the mobile network controller, which would then say, hey, I've got a whole bunch of packets of information. These are the same ones. It does the deduplication. And then it decides when the network wants to talk to this little clicker, it decides, well, which of the base stations was closest to this clicker, and then routes the return message through the nearest base station. LoRaWAN also adds an adaptive data rate scheme so that devices that are near to base stations talk with a very complex modulation, so the message gets through really fast. Devices that are really far from the base station talk with a really simple modulation, really, really slow, lots of airtime. LoRaWAN also adds multiple layers of encryption, network encryption and application encryption. The cool thing about this, I say I've been working with LoRaWAN for 4 years. I've been a network operator, and I have no idea what the end users of the applications are doing, because all I see is encrypted packets and metadata going across my network. I don't know what's in the data, and I can't because I don't have the keys to unlock that data. So LoRaWAN also supports time slot scheduling of device transmission, and makes everything harmonious when you've got thousands of devices talking to a couple of base stations. Next, please. So the various entities in a LoRaWAN network are end devices, which is my clicker, gateways, which I don't know, we could call these massive chandeliers a couple of gateways. Then in a lot of networks, the gateways use LTE or 3G backhaul, but they could use fiber backhaul, ADSL backhaul, whatever, to get into the network server. In the case of my network, the network server is an application that runs on AWS. In our case, we use AWS Sydney for New Zealand network. We use AWS in the Bay Area for our Cook Islands, Rarotonga network. And then there are applications, and applications could be separate from the network server, but in the case of most LoRaWAN controllers, applications are bits of code that sit inside of the same computer that's running the network server. Complicated. Next. So I'm going to give you a very quick LoRaWAN architecture overview, and this is based on RFC 8376. This is so appropriate for being at an IETF meeting. I'm just going to walk you through LoRaWAN based on the RFC that we're all writing our network software to. Next. So there's an end device, that's our clicker here, sometimes called a moat. It communicates with the gateways. It never talks to another moat, never talks to another end device. Everything is always through a gateway, through a network controller, to an application, and then from that application back down the chain to the end device. This guy has a unique, globally unique identifier called a device EUI, and that's an IEEE number. And it has a network unique identifier called a device address. That's a 32-bit address. We're talking sometimes about sending like 1 or 2 bytes of data. So when you start adding a 32-bit address or a 64-bit address, you've got a lot of overhead there. Anyway, next. So our end devices. Here's an example of an end device. This is just an example. Next. People, you can look at the slides later. There are 3 classes of devices. The ones that are used most often are Class A. Communications is always initiated by the end device. It's a node, it's out there, it decides, hey, I've got a bit of data I want the rest of the world to know about. It sends the data, Aloha based. So it could be that that data doesn't get through the first time, whatever. Eventually it sends the data and it's acknowledged, and that's all good. After it sends the data, it listens to the network to see if the network wants to talk to it. So there's a time slot set up for the network to reply back and say, hey, I got your data, or hey, I got your data, now go to sleep for the next 6 months because I don't need you for then, or some other message. Now, Class A is lowest power. Class A is great for a battery powered device that's out there in the environment doing environmental monitoring, needs to last forever. Class B, on the other hand, listens to the network on a schedule. Say maybe it wakes up once an hour and listens, wakes up once a day and listens, what have you. Very uncommon Class B devices. Most commercial implementations are either for Class A or for Class C. Now, Class C is just fine if you have solar power or electricity or just some massive source of energy, because it stays awake all the time listening to the network to say, hey, does the network need me? Think about a farm and you've got a whole bunch of Class A devices out there measuring soil moisture, and they're sending their data up. They're all battery powered, whatever. But then you've got a solenoid or a valve on the water system to add more water. That can't just be, asleep all the time. It needs to know, does the network want me to turn on and water the grass? So use a Class C for a control mechanism on the water. Next. So LoRaWAN gateway. It's a radio on the infrastructure side. These italicized are actually straight from the RFC. I've noted that I've actually lifted phrases straight out of the RFC to describe this. So sometimes gateways are called concentrators or base stations. I use base station and gateway like interchangeably. They communicate with end devices via the LoRaWAN protocol, and they communicate with a network server via TCP/IP. In the case of the base stations that I manage, they use WebSockets. In the case of the original implementation of the Things network, there were UDP packets going from the gateways to the network server. So gateways, you can put a LoRaWAN gateway on a base station that's running other things like Bluetooth or Wi-Fi. I have Linux boxes that run LoRaWAN gateways, multiple instances on the same box to deal with multiple radios, and they might run other things, packet processing software or Wi-Fi or whatever. It's just a software application that interfaces with the radio. Next. So here's a few examples of LoRaWAN gateways. And yes, I've used all of these little boards and multi-techs and things, networks, things, and whatever. Next. So a network server is a piece of software. It terminates the LoRaWAN MAC layer, even though there's some TCP/IP in between. For end devices connected to the network, it's the center of the star topology. You've got stars of gateways and stars of end devices. The network server decides what gateway is going to talk to what end device. And it's also going to tell the end device what data rate it should be transmitting at so that the gateway can best handle the amount of traffic and the amount of signal coming from close nodes and far nodes. Next. So here's some examples of LoRaWAN network servers. The one I use in production is LoR IoT, which is a Swiss company, but I use the Things network for training workshops. And I've got a Things network connected gateway in my apartment in Singapore now because I really love what they're doing and I really like the features of their network now. 4 years ago, it wasn't an option for doing real applications that you wanted to work, and today I think the Things network is good for anything. Next. So a join server. Okay, this is super complicated. Devices have sets of encryption keys going on. A join server is what allows devices to get on the network. Go to the next. It's usually combined with a network server. An uplink message is when the node talks to the network. And yes, the uplink can be listened to by multiple gateways. Go on, next. Downlink message is when the network is talking to the node. And again, the network controller, the network server is what decides which gateway is going to send that message. It's also going to decide whether that message is going to go to a single end device or to a group of end devices. Next. Now, a LoRaWAN application is application layer code that's running on the end device, and it's application code running behind the network server, and there's a set of encryption keys tying these things together. Most end devices will only ever run one application. This is kind of how LoRaWAN has evolved. You have individual devices that do very limited, simple things, and they only talk to one application server. So applications typically run on network servers. Applications do device management. Which devices are allowed to talk? What are they allowed to do? They route data to external applications, and that means they offer up an API that says, right, you can get data out of this LoRaWAN application via WebSockets, via MQTT, via JSON, via HTTP GETs, or what have you. So it is a misleading name. We could be calling these applications application routers. Next. Encryption. All payloads are encrypted. So I said I'm a network operator. I have no idea what my end users are doing with the data. That's because the payloads are encrypted. I don't have the keys to open that. There's also data integrity. So there's sequence numbers that are encrypted that I don't know about, but the application owner knows about. So someone can't record a message and do a replay attack. Someone can't attempt to insert random messages in there because they'll be out of sequence and they'll be rejected. There's also data integrity because there's checksums along with the encryption. So you can't change the data in flight, you can't intercept, you can't replay, blah, blah, blah. MAC commands are protected. So nobody out there listening to the network can actually see any of the metadata associated with these transactions. In fact, if they're just listening without the network encryption keys, it's just noise. In fact, a lot of times it's noise below the noise floor. So it is really almost undetectable and impossible to see what's going on. Next, almost done.
Yep, we have about a minute.
Right, pre-joined devices. You have ideas of devices that you join to the network once the end user has the device in hand, and then you have the idea of devices where the manufacturer of the device joins the network ahead of time before they send it out in the field. And in this case, the device is pre-joined to the network. We put symmetric keys, 2 symmetric keys in the firmware of the device before we send it out to the field, a network session key and an application session key. These session keys they are session keys. So they can get rolled later, so they can get refreshed down the road, and frequently will get refreshed every time they rejoin the network, but this gets them on the network to start. Next. And there's the idea of an over-the-air join where the network operator will send out a network session key and an application key, and the user will write those into the firmware, and then the device will send its device EUI, its app EUI, and its app key, and the network will basically derive app session keys and network session keys, those ones that if we did a pre-join, like in the last slide, the network and the device derives those things in a cryptographically secure manner so that these devices can talk. Right, next. So what is the things network? All of this complicated stuff to do with the network server. Like, this isn't easy stuff. And I've never run my own network server, although I've downloaded the code and tried before. The Things Network is a free distributed network controller that a group out of the Netherlands put together so that people could have community LoRaWAN networks. They said, well, look, we're going to write a software implementation. We're going to make it all open source. We're going to have the community work on it, and we're going to let anybody who wants to connect to our network server spin up their own applications, generate their own keys, and join their own devices to these networks. So TTN, the Things Network, it provides a network server, join server, and application servers in one. You have a nice web interface, a web platform that allows application owners to register devices. I could use the Things Network if I just had a login to create an application and some devices, and I used someone else's gateway. In a lot of cities in this world, there are enough gateways that you don't need to run your own. Or you can be like me here in Singapore. I provide TTN gateway out of my apartment, but I don't actually have any applications running on it. I'm just running the gateway because I can, and I like the idea of it, and maybe I'll run an application at some point. All gateways on the Things network process all traffic from all devices joined to the Things network. So it is truly a communal thing. In Europe, they've got very strict restrictions on how much airtime your device can use so that an individual device can't take up too much network resource. So TTN provides all of this for free. They also help communities organize and communicate by giving them space on their website and allowing them to open up chat channels and post notices of meetups and so on, and linking their profiles in. So when I came to Singapore, I said, what's the TTN community in Singapore? I went and I found people's LinkedIn profiles on the TTN page. I sent them messages. I said, what's the story? What are we doing? When are our meetups and stuff? Same thing when I did a workshop in Santiago, Chile last year. I went to the TTN page. I found that they had a Telegram group. And the Chilean TTN community, LoRaWAN community, is just fantastic. There's like 30 people in the Telegram group. There's new posts all the time. And if I spoke Spanish, instead of having to paste everything in Google Translate, it'd be really, really neat. So heaps of TTN all over the world. So where is the Things Network? Yeah, this is how many there are. There's more than 200 cities. And there's extensive coverage in some cities. It's pretty cool. I know University of Hawaii has just spun up a couple on my recommendation for some data collection things because they needed to do data collection and they wanted an open platform, so TTN. What else do we have? We must be almost done. Next. Here's a view of the console if you're logging in. That may be a bit small for anybody to see, but you can see my gateway there and some of the things I can control, and the fact that there's a gateway ID. There's those gateway IDs and things. Next. So what does TTN integrate with? TTN provides these applications, and all the applications do is route data. So there are cloud applications you can use to talk to TTN, and some of those include Cayenne My Devices, Open Sensors, Mapper, Colos. I have no IFIT. Some people in here will know what IFIT is. It's a platform that allows you to do things based on data. So in addition to these integrations, which are like super easy to set up, you can also just get JSON data or just get WebSockets data or whatever out of the controller. Next.
Okay, we have 1 minute.
I think we're at. That's it. So I've just got pictures of devices. You just scroll through that. Next one.
That's it.
Is that the last slide?
That's the last slide.
All right, so that's it. So yeah, I guess any questions?
Anyone have a question for John? We have a minute.
Cool.
Marie-Josée Montpetit, I have a question for you. I saw your map. My question was about your map, like a few slides before.
Yeah, go to the map, please.
I see that you have some presence in North America. I've been part of a group who started looking at communication in northern Quebec, and I see you have no dots there. Northern Quebec, by the way, is eastern coast, go up, up, up. And it's the big thing that right now there's no dots in it. And I was wondering if you guys have thought of your same type of communication in remote areas in Canada, which will never be served by any form of, broadband, traditional network, yet have an incredible need for communications and for access. So I was just wondering if you had plans in Canada. I see you have Alaska, which is cool, but nothing in my neck of the woods.
This is a group of communities, and so if your community wanted to start a LoRaWAN network, your entry cost for a gateway is less than $100. I think it's around $70 US. You can buy a gateway, and you need IP backhaul. Now, the amount of IP backhaul that you need to run this is in the kilobits per second. So any satellite connection would solve this problem.
Well, actually, one thing I wanted to, well, we can talk offline too, but in these northern communities, they always have credit unions, and those credit unions have some form of connectivity. Yeah. And we had thought of using them as hubs.
it's a very good idea to use those as hubs.
That's a great idea.
Thank you.
Okay, thank you. Let's give John a round of applause. Thank you, John. And John works with NSRC sometimes, and they're a great partner, and Dr. Quintana knows them well. So the next speaker is an online speaker whose name is Francisco del Aguila, and I've probably not said that right because he's from Barcelona. Francisco, can you hear us?
Yeah, yes. And
Bravo. Okay, so give me 1 second to pull up your slides. Can you introduce yourself?
yes. Hello, everybody. My name is Francisco del Águila, and I am an associated professor at Universitat Politècnica de Catalunya. I live in Manresa, and a city in Barcelona province. I managed to deploy a fiber optics network in my neighborhood, and I'm going to show you how was it. A description.
Okay. Yep, your slides are up, so go ahead.
Yes, please. Could you put in a size greater?
I can't with this computer, so I'm gonna have to ask you to hang with me and just go with what we got.
Okay, no problem. A description of the initial context is that Viladordis is a small rural nucleus of about 300 inhabitants, 3 kilometers from the city of Manresa. And Viladordis is also considered a neighborhood of Manresa, with a nucleus with concentrated houses and also scattered farmhouses. Existing communications were very precarious. ADSL with low bandwidth, below 1 megabits per second, and with continuous cuts. And also the other possibility was WiMAX communication with low capacity and high prices. Next. In 2010, there was an initiative to improve communications. It was a construction of a community wireless network. The initial support was of about 12 houses. This network has been working since that moment. Also, community maintenance was done in associative way with a person with technical expertise to carry out the maintenance. Every household did an initial contribution of 35 euros to get the rate of connection and also to buy initial equipment. Private equipment per household cost about 200 euros. And after 5 years, the final support was about 35 homes. Quotas for household were of 40 euros per semester, and a creation of reserve funds to deal with extension and maintenance was done based on surplus quotas. Next. About the feasibility study, first of all, an estimation of cost was done. A budget for the creation of a fiber network to connect to the next point of a common fiber network 10 kilometers away was of about 45,000 euros. The priority was to set up a fiber backbone to reach the community wireless node. The first phase was to obtain funding to reach the community node. The second phase was to allow planning to finance fiber to the interested homes. Next. About financing and co-sharing between neighbors, one of the important things was freedom to choose between a mandatory contribution from each home to build fiber optics to the wireless node it was 600 euros, or optionally increased contribution by anyone who wants fiber to home. In this case, it was 1,500 euros. About 50 homes are required to carry out the project, and a survey was done among neighbors. Few families refused to contribute money. One part chose fiber to the wireless node, another part chose fiber to the home. Finally, the number of participants reaches around 50. The surplus money reached 5,000 euros and becomes a buffer. The Giffy Badges Association, the current provider, is requested to contribute with another buffer of 5,000 euros more. The Spanish law allows individuals to deduct in donation made to foundation the first 150 euros up to 75%. Above this quantity, the deduction is 30%. The GiffyNet Foundation dedicates donation received to the creation of a communication network of universal reach and available to everyone. So finally, the Viladordis project was activated. The funding collection phase was started as the first action of the project execution. For 2 years, 600 euros per household is collected in the form of donation, preferably of 2 people per household with 150 euros per person. It's also accepted that some households do not contribute with this amount in exchange for contributing with 100 euros per year forever. We have now the table with the different contribution options. 2 of them to get the fiber to the wireless node, and 2 of them to get the fiber to the home. In the first row, we have the years, and between 2016, 17, and 18, the network was based in radio technology. But at the end of the 2018, the network of fiber optics was built, and we are enjoying this network today. Next, please. In summer of 2018, a fiber installer is contracted to carry out the deployment. The installation is carried out during the next year after the donation of 600 euros. Households committed to fiber at home contribute until reaching 1,500 euros. At the end of the network installation, 30 households made the donation of 1,500 euros. At the beginning of the next year, more or less nowadays, 10 households more are going to donate the total amount and are waiting for the fiber installation. Now you can see a summary table of final income and expenditure. For example, about income, we have the quantity of each household with each option. And finally, we get the amount of 61,000 euros. About capital expenditure, we have to pay the main backbone and also a branch line of a little village, San Fritos, and a branch line towards the city of Manresa. We have also, for everyone who wants fiber to the home, we have to pay for the user drop. It costs about 200 euros, and the final amount you can see in the slide. Finally, you can observe that we have a surplus to extend optical fiber to other locations. Next, please. This is the map of the deployment, and you can see very well, but in the top of the map, we have the point that the network is connected to the previous fiber optics network, and from the top to the bottom, we have the main backbone. And if you can see, the blue line are a cable of 48 fiber optics, and the green one is a cable of 12 fiber optics. You can see also the two branch lines, one of the towards in the right top of the map towards San Fritos, and in the left bottom you can see the branch line towards the city of Manresa that you can see on the left of the map. Next, please. You can see any example of the deployment. For example, the building facade with a connection box, the name of GIFInet, that is the main, is the project based on this deployment. Next. You can also see the deployment based on pole installation with a connection box also. Next. And nowadays we are in the maintenance stage, and we have an agreement with installers of a commitment for repairing when any failure. A monthly donation of 6 euros is made as part of an economic buffer to pay the eventual maintenance. I mean, operation expenditure. The resulting fee to the user, if he chooses GIFI Association as operator, is 15 euros per month, where the 6 euros of maintenance fees is already included. Internet access is achieved through a regional optical backbone over a wholesale-only fiber operator connected to a shared pool of internet carriers in Barcelona, both operated by the GIFInet Foundation. And finally, as a conclusion, it is possible to have a broadband communication in rural areas where traditional operators do not see any kind of interest. Coordination between networks is needed to provide the necessary funding. It is necessary flexibility for each individual to find their place in the project. Tax deductions are great incentive, since that leads to the final cost being approximately a quarter of the total amount. The Neighbors Initiative has been possible thanks to the existence of the GIFInet project, with the presence of different actors such as the Foundation and also associative operators as GIFI Badges Association. The final existence of this network promotes other neighbors to join later. And that's all. Thank you for your attention.
Thank you very much, Francisco. Does anyone have any questions for Francisco? We have about 2 minutes. If not, we can make sure that you have his email if you want to contact him. And Francisco, is that okay?
Yes, please.
Okay, good. Just GDPR. Just wanted to make sure I was getting that right. So thank you, Francisco. Francisco comes from GIFInet, one of the largest community networks in the world. And some of the people in the room, Francisco, are shaking their heads because they know GIFI. Thank you very much. We appreciate your contribution, and the slides are online already if anybody wants to take advantage of them. So, gracias.
Thank you.
Thank you. So if anyone's in the room that hasn't signed in with the blue sheets, please do so. They're circulating. The next speaker on the agenda is Maria Teresa Perez, who is here with us in the room. Maria Teresa Perez has 10 minutes. She's going to stand on the X up here and speak into the microphone. The clicker's not working, so I'm going to help you. If you're in the room, you are here for Gaia. Let's see. What are your slides? Community Cellular. There you are.
Okay.
And so I just also want to recognize that many people who came here today from Dr. Kanchana in Thailand, well, Francisco, through the beauty of the internet, is speaking with us from Spain. We had John, who's originally from New Zealand but lives here in Singapore. And we have Maria Teresa from the Philippines. We soon will have Ono, who I believe is from Indonesia. So you're seeing local people and others who are connecting through Gaia and other ways at IETF and through different organizations to learn more from each other about the deployments that they're actually making to connect people in really remote, rural, and sometimes urban poor situations. So over to you.
Okay. Hi, I'm Maria Teresa Perez from the University of the Philippines. My talk is about community cellular networks in the Philippines, experiences from the VBTS project. So the outline of my talk will be as follows. Next. I'll be talking about CCNs in the Philippines, and then our deployments. I will show you our challenges to sustain these sites and what we think is the future of CCNs in the Philippines. Next. So as we move towards digital society and internet connectivity, there are a lot of people that are still not connected or do not have access for communication. So GSMA data shows that as of 2018, the Philippine subscriber penetration is only at 64% of the population. Next. This is especially true for rural remote areas because of the following reasons. First, most barangays lack grid power. There's also high installation cost of traditional base station deployments, and it is considered unprofitable for telcos due to small subscriber population. Next. So what we did is to partner with telco and local communities to deploy community cellular networks. So CCN is a cellular technology at a tenth of the cost of traditional base station deployments. So it is low cost, low power. It uses alternative sources of power, in our case, solar. It is customized network for small communities, and it is being managed locally by the cooperatives with the help of the local government unit. It has a community-owned model where the community owns, operates, maintains, and repairs the CCNs. Next. So here is the basic VBTS diagram. You have the GSM 2G base station, antenna, the power source, and the VSAT to connect to the cloud. Next. So, but before we can even start deploying these boxes, we had some pre-deployment challenges. First is with our telco partner. Since 2G frequency bands in the Philippines are assigned to incumbents, we needed to had an agreement with the telco operators, and this took shape for around 2 years of negotiations. But with that agreement, we had an 80-20 revenue sharing, 80 for the community and 20 for the telco operator. They are the ones handling the regulatory permits. We had to get the SIM cards from them, and they also handled the interconnect. Also, we also had a problem with the regulatory since we initially set to use experimental network-in-a-box solutions that we also developed in UP, but we were restricted to use type-certified boxes or network equipment. In the course of our deployment, in the course of our deployment, we have an ongoing impact study of first-time access to mobile communication in rural areas. It uses randomized control trial to determine these 7 pilot communities. Next. The communities we serve are remote and isolated coastal communities with typical village is around 2 to 3 hour boat ride from the nearest mobile phone tower. Next. They are fishing and farming communities, and the locals travel for several hours to use their mobile phones. On the other hand, the local government unit uses their high frequency radio links for emergency. Next. So the timeline of our deployments, from September 2017 to January 2019, we were able to install and deploy in 7 sites in 7 communities in Aurora province. Next. This is our typical installation. You have the solar, the equipment inside the shelter, VSAT, and the picture of our cell site. Next. So the status of CCN, we have 7 community sites. We have around 2,000 or more than 2,000 subscribers in our 2-year operation. Our monthly average traffic is around 10,000 voice minutes and 2,000 SMS average. Next. So here are the observations we had in our sites. So SMS is the predominant traffic with equal volume in both directions. And inbound call traffic is almost 6 times the outbound call traffic. This is an indicative behavior of a call me behavior, because subscribers found out that they are aware that they could save by letting their contacts call them instead. So just to note that we do not have promos yet in these sites. So other observation, they have a peak usage in the evening. So subscribers prefer to call after work hours. Next. Other observations, we do not have promos yet, but there are frequent inquiries on the future availability of promos and internet access, notably Facebook. So others, demands on service availability changes as time goes on. So people are now becoming accustomed to the presence of our service. So there is an increased sensitivity on our service disruptions. So next. So here are the challenges. We think in order for us to continually serve these communities, very first, of course, is regulatory, because in our current structure, it is highly dependent on telcos. The telcos' expansion plans and priorities, and we are heavily tied to the end of our agreement with them, especially now because we are nearing the end of our agreement. Also, we are regulatory, also the equipment type certification and the permits to purchase. The only ones allowed to purchase, possess, and operate this network equipment are the telco operators. Operation is the backhaul availability, because currently VSAT is the only solution, feasible solution for a true drop and operate deployment. Next. Other challenges also in the service perceptions, because there are higher expectations now on the operational hours and reliability, and we are now being compared to the incumbent MNOs. And lastly, since we heavily rely on the local partners on the ground, we are having a challenge in the personnel retention, as designated maintenance officers that we also trained moved to more rewarding livelihoods outside the community. So what do we see as the future of community network in the Philippines? We see the internet as a way to move forward, either as an added service through cellular data or LTE, or an internet-only network. But in the cellular data option, we will have a high dependency in telco partner, and the cost of bandwidth is also high. To eliminate this dependency, we are seeing that we need to have more policy revisions, like we hope to have a legal framework for CCNs as a mode of community-based social entrepreneurship. Also, we want the policy revision that we have a reform of the system, that hopefully they can allocate spectrum and license towards the designation of a social use frequency for the CCNs that we have. And for the internet-only network, we see that the eventual phase out of 2G and the proliferation of internet-capable phones points us to a internet-only network, but internet in the last mile areas are not cheap. So efficient bandwidth utilization, like what was discussed before, we are also exploring that. The utilization strategies for the bandwidth should also be explored. So next, this is my last slide. So we hope that by sharing our experiences in VBTS in the Philippines, we hope to open more opportunities for these communities, expand coverage, and connect more people to the rest of the world. Thank you.
Thank you. That was great. We have about a minute and a half or 2 minutes. Does anyone have any questions for Maria? And I have to say, something you mentioned about the regulatory issues are major things that we see around the planet. Mallory, can you introduce yourself?
Yeah, hi, Mallory Noodle from Article 19. Really interesting work. I was just wondering if you could give us a sense of where you're at in the policy advocacy process in the Philippines. Like, do you have draft laws? Do you have white papers? What's happening there?
We don't have policy draft yet. So we only have local copies of the draft we are trying to create, but we are not yet in that stage. Thank you for that question.
We have a colleague named Noelle who lives in Manila, so we're going to introduce you to her. She's fabulous. But also, you mentioned a social purpose or social use. There is, and thanks, Mallory, for that question, because it's triggered a memory. In Mexico, they have a social purpose license, which they were one of the first governments in the world to actually do this to help indigenous communities get connectivity. So it allowed the network to exist, which prevented the incumbent from killing it off. In many countries, the incumbents and traditional mobile operators cannot get a return on investment in rolling out in communities of 5,000 and under. So there you have this issue. They can't get the return. The community networks can't get the regulatory licensing, and yet they can go into these communities at a lower cost. So Mallory's question is super important because this is something we're all dealing with community networks and small operational networks, where we have regulations for the old system. The old system doesn't reach the unconnected. It's not cost efficient. The newer networks and the cheaper guys with great equipment out there with your network and the others here can provide the connectivity, and they just need the backhaul on occasion. So I'm going to offer a modest proposal that a lot of governments start to change the way big operators can actually get licensed so that they are required to provide backhaul to the little guys, because we are never going to get people connected if we don't have a change. So anyway, you are doing a great job. Thank you very much.
Thank you.
And Ono from Indonesia, I believe you're up next. Thank you, Maria. We appreciate your time. This is the cool stuff where people are actually deploying networks in hard to reach places at low cost and a lot of effort, human effort. Which presentation's first?
ID Village Rural Internet.
Okie dokie.
Okay.
This one?
Yes.
Yes. Okay. You're up. You have 10 minutes per presentation, but we have
for both of us.
Yes, please. And
Yes.
so we have to be cognizant of time. So if you can take about
I take around 2 minutes or 3
voila.
minutes.
Okay.
Okay.
Go for
Thank
it.
you very much, Jane. Thank you very much for everybody for coming to the session. My name is Ono. This is Aji, and Bara is sitting over there. He's taking filming us, and we will upload to YouTube. Hi guys. So that's YouTube stuff. Okay, next. I will be very provide a broad overview of what we are doing, some do and don'ts, and next Aji will tell us about his experience connecting about 200 plus villages in the last 4 years, and he's actually connecting like the neighboring municipal another 200 as well. So total, I think they are managing to connect around 1,000 villages right now. Okay, next. So in Indonesia, we have 80,000 village, 9,000 in no signal, no nothing. 50% of the population is in the village. Okay. Right now, we have what Kancana called community network. We have 60,000 community network in Indonesia. Mind you, it's all illegal. Okay, next.
We don't mind. Sorry.
So this is what Jane pushing. How to push the government policy to be more pro people policy. We have 4 options: use power, use money, use mass or people, and international acknowledgement. Use power, we have no power. We use money, we have no money. We broke. We use mass. We educate people. If we see the next presentation from Aji, we will see clearly how they actually educate a lot of people, but it failed. It's still, we are having difficulty to push the government policy, having a lot of people. The most efficient way is international acknowledgement like this. So we are very thank you to Jane and all of you to invite us to be able to give talk to all of you guys. This actually creating a lot of pressure to the government that what we are doing is actually right. So we like to thank you about that. Next, Don. This is what the most of the government done is top-down approach, very much project-based, and it costs us, the Indonesian, $60 million and becoming scrap. Next, the do. Very much community-based. You can check on Google. The keyword is, in Indonesian language, is wajan bolik. In English is wok for cooking, and parabolic. We mix together these 2 words, becoming wok bolik, but we have to use the Indonesian words. You can see a lot of pictures of this type of antenna. It's becoming very Indonesian style. So the technology becoming owned by the Indonesian people. Okay, you can check on Google. Google noticed it. Okay, next one is Kancana used the word community network. In Indonesia, we call it RT/RW net, which is neighborhood network. If we enter the keyword in Indonesian language RT/RW net, you can see lots of Indonesian sites carrying this kind of technology. This is illegal though. Okay, so next is Aji, your stuff.
Which one is it?
Rural.
Other things.
I think you already shown.
Hang on.
I did. The Pemalang.
The Malang. Hang on.
Pemalang.
Yep. 1 second. Poof. Poof. Just fine. Yeah. It's right. Did you see it?
No.
In
It's
the downloads.
Pemalang, not this one.
Do you see it? No. Hang on. That's okay. It's right here. I uploaded it before.
Yeah, I saw.
Technical moment. One thing I think that's very curious about most of these community networks, and when you mention the word spectrum, everybody gets excited. It's a very complicated thing with some of the governments because spectrum is
fixed version.
Gotcha right there.
Yes.
Perfect. 2 seconds.
Yes.
There you go. The fact that these networks are illegal just makes me very cranky, but
It's too slow for you.
Oh,
For us, it's fast.
No, I used to live in places too where that was this was normal.
Oh, your slide is too big. Slowly.
That's okay. I bet you have pictures.
Yeah, he has 10 meg or something.
It's okay. It's coming. Can you tell us where you're from?
Okay, everyone. My name is Sumitra Prabowo. We are from Puspindes Pemalang Regency, Central Java of Indonesia. In this section, I will tell you about developing the rural internet in Pemalang society. Refresh.
We're just waiting.
Aji is the one who actually coming from the real village. So apology for his English. So Aji is from Bara and actually from the guy who actually on the ground. I'm little bit illegal because I'm from Jakarta.
This is sorry about this.
You need to refresh?
I don't think refreshing is going to help. Oh, it's throttling. Oh, welcome to the throttling. Yeah, golly. Okay, let me see something.
Download. Download.
No.
Pakai slide aja deh.
Okay, while waiting, I will skip something. So we reload. Okay. So while waiting for the slide to load, we managed to negotiate with the government. So to give you some idea how tough our job is, in the past, Wi-Fi is not free. We have to pay about $2,000 per year per access point to the government. So we fight with them, and finally, 5 January 2005, Wi-Fi is liberated. So we can use Wi-Fi for free. So all this network are Wi-Fi based. We modify the antenna for long distance connection. And then we are not using like Philippines cellular yet, but Curtis managed to run now legal. Thank you very much. So Curtis managed to run cellular network in Papua for, I don't know, 6-7 years. I don't know. Couple of some years, and becoming example for the Indonesian government. Finally, 2018, the government signed an act that we can experiment with any technology in rural for free for experiment. And Curtis and I goes to the government and asking which frequency we can use, and the officer tell us we can use any frequencies. So Curtis is very happy. So all because of Curtis. He's the one who's responsible for this. So frequency is free, and we can use for experiment. And now I don't know how many BTS is deployed by you guys. I don't know. Oh, you won, David. It's more than 5, I guess. Huh? Oh, okay.
Does anyone have this on a flash drive?
Oh, yeah, yes, I did.
Okay. No, don't worry. I'm the one who's sorry.
I don't know. My mind is free, so.
Mine's freezing too. It's okay.
I'm impressed with you, Jane. So
no, don't be impressed. This is like panic mode. Sorry about that, because this anyway. Let us see if we can find you here.
It's called, I think, IETF or something like that. The folder.
Okay. I thought I had you up here too.
Oh, that's the one. That's Ubuntu. Oh.
Okay, hang on. Where's your device? Anyone better on Chromebooks than me? Where would we have the... Sorry? There we go.
Removable detected.
And hopefully it's okay. It has loaded it. I don't know where it is though. But there's the files. So it's somewhere on there.
Which one is it?
Not that one. Is that my drive?
Yeah, that's your drive.
I think I formatted. No. I think I formatted. Wow.
All you have to do is pull the HDMI cord and put it in here and you get it working.
Go for it.
This is the right presentation?
Yes, yes, yes.
Okay.
Oh, thank you very much.
Yeah.
You saved our life.
Sorry. I usually have more help. Okay.
Oh, okay, thank you.
Yeah, you stay with me. Takes a village. Here we go. Okay.
Okay.
You guys are on.
Thank you.
Thank you.
In this section, I will tell about developing the rural internet for Pemalang society. Next. Okay, this is Pemalang Regency. Pemalang is one regency of Central Java province of Indonesia, which is located on the north coastline. Administratively, Pemalang Regency divided into 40 districts and 211 villages. Besides, the territory divided into lowland and highland. Next. This is some images of blank spot area. In black color, this is lack of coverage signal area, and green color coverage signal area. Please, next. Limit internet information, the transfer data manually and transfer in communication with other is problem at the time. To overcome this problem, we develop the internet access to cover this area by funding society. Next. This is some image process of building internet access. You can see we work in jungle and some tool. Next. This is documentation we built in. We build tower in every village. Next. And that map, that monitoring map of internet connection using Ubiquity network management system. We use wireless technology to connection every village. With internet access was built, we conduct to proper training to the community. Next. This chart shows the training participant that consists of some element of society. Next. And this slide shows some images of training activity. There were 5 times training activity totally in 1 year. Every type of training was held in 3 times meeting. Next. Okay, this is in the slide shown some images training network training activity. You can see they are playing cable. Okay, in this training we talk about routing, network maintenance, network design using Cisco, bandwidth limitation, IP address, and other. Next. Okay, this is VLAN map training. In this training, we talk about VLAN boundaries, how to make maps with drone and other. Next. This is in the slide some image of VLAN information system training activity. We socialization the system to the community. Next. And this is a VLAN information system that we create. We call it SIDACOM. By using SIDACOM application, now the village is able to provide some fast service to the community. Next. Okay, this is a basic computer training activity. In this training, we talk about LibreOffice, Chat, Impress, Reader, all we discuss about open source application. Next. And we also held an annual activity. We call it Jamboree IT or Information Technology in Jamboree. Next. This is a social media website and journalistic training activity. We train the community about using a social media, how to manage complaint handling in social media, and share information in social media. Now, 10 village official accounts have been verified by Twitter. In addition, we train the village official to manage village government website and also journalist training, include how to create online store, talk in website. Next. And in this slide, shown the Internet of Things training activity. We introduce several tools such as Arduino, Spectro, and several sensors that can be implemented in villages such as agriculture, etc. We conduct all the training for free, all funding mostly community. Next. And in 2018, we achieved the prize in the sharing knowledge category awarded in WSIS in Geneva, Switzerland. Thank you.
That's it.
Wow. Thank you so much. We have a couple minutes. Does anyone have any questions for the team here from Indonesia? And thank you for coming. And Curtis. Thank you.
I'm allowed to have questions. So Curtis Heimerl, University of Washington. I'm curious about the use cases for the IoT. Like you set people up with Arduinos, all that. Was there any uptake or use of those in the network?
He's afraid to answer your questions. Okay, to be honest, what they are doing at the moment still in early stage, but I have to show the video. There is a junior high school girl building an IoT for hydroponic farming, but this one is not in that area. It's not far away from that area actually in Yogyakarta, so in the mountain in Yogyakarta. So yes, they are doing something like that in village.
Cool. All right, thank you.
But I like to learn from John actually. Laura one. I skipped that thing the other days, but after seeing your presentation, I think I will learn. I will read a lot about that. That's cool.
Excellent. We have someone at the microphone. Please announce who you are.
Hello, Philip Martinez from UP. This is a remote question. I should ask, where do you get your backhaul connection for the internet?
The backhaul?
Yeah.
Saya aja. They are afraid to answer questions. So basically, they have a center. They call it Puspindas. That's a center organization, and they run some sort of internet exchange. So a lot of connection, ISP connection to this one. How big is the bandwidth you have now? 100. The total bandwidth 110. Right now, total bandwidth 110, but multiple ISP.
Thank you.
And they share it to the other villages. And we run a lot of local server, like streaming video, voice over IP, so all server locally. We are, yeah. So we have a lot of local server. Unlike Kanchana, who cache, she's very polite, caching the video. We actually set up our own streaming server. Sometimes we put the illegal video.
No. Hey, it's okay. You gotta hack the network, right? So, excellent. Well, thank you very much. No, don't be sorry. I think it's fabulous. I may not look like a rebel, but in my heart. So I'd like to just thank everyone for coming. We're going to have to wrap up, but these fabulous people who are actually building networks in very hard to reach places with very little money and a lot of energy are here. And they're learning from many people here at the IETF. They're here to talk about open standards because they're deploying them in their networks. And these are actual networks. They're not high-grade commercial networks, but they are good networks in the regions, and they're being developed in a very interesting technical way because oftentimes they have to get hacked. And oftentimes the governments aren't allowing them in places where there is no connectivity. Go figure. So Leandro, my counterpart from GUIFI, is telling me that in Vancouver at the next IETF, we are going to talk about the importance of our next steps on hacking documents with you to discuss some of these networks and provide more examples of these networks. So if you'd like to join our mailing list, you can find it online. That's the Gaia mailing list through the website. And we're going to be looking at the interface between CNs and IXPs, wholesale operators for fiber, which is like the GUIFI network, wholesale fiber, different community networks in LoRa, LoRaWAN, Wi-Fi, GSM, and other. And so we'll be combining our efforts with all of you from around the world. Please join the list. We'll hack this together, and we'll do more at the next Gaia meeting in Vancouver. So thank you for your time. If you haven't signed in on the blue sheets, please do. That's much appreciated. And just thank you for your time because this has been really, really cool. Thanks. And thank you to the person that gave us the... He saved the day.